Hello, and welcome to a presentation on Earth's closest planetary neighbor, Venus. Because of Venus's proximity and similarities to Earth, it has been referred to as Earth's twin. Venus is unique among planets in many ways. These include the fact that it has no moons, it is the hottest planet in the solar system, it has the most volcanoes of all the planets, it is the third brightest object in the sky after the sun and the moon, and boasts a surface pressure 92 times greater than what is experienced here on Earth. As previously mentioned, Venus shares some significant similarities to Earth. This table, that we previously used to compare planets for our recent discussion board assignment, shows that Earth and Venus are similar in size, mass, and density. These similarities are mostly due to the two planets forming at similar distances from the Sun. However, you will soon see that the similarities end here, and the two planets are very different from one another. When comparing Earth to Venus, the two largest terrestrial planets, you can see how they are nearly the same size, especially when seen next to the much more massive Jovian planets. One of the most interesting facts about Venus is its extraordinarily slow rotation. Not only is it slow, but it is retrograde, meaning that it spins clockwise, opposite the counterclockwise spin observed in most planets. This unique behavior is thought to be the result of Venus colliding with another large body early on in its history, resulting in a big deviation from what would be expected without such an event taking place. The slow rotation of Venus means the planet takes 243 days to complete one full spin on its axis, which is longer than it takes to orbit around the Sun one time. This means that a day on Venus is longer than a year on Venus, and a solar day on Venus takes 117 Earth days. The rotational period of Venus is more than any other planet by a considerable margin. Mercury has the next longest rotation of 59 days. Venus never wanders more than 47 degrees from the Sun in the sky, so, when visible, it is seen around sunrise or sunset. It is for this reason, along with its brightness, that it is often referred to as the morning star or evening star. The following slide will explain this observed behavior. One might think that Venus would achieve maximum brightness when it is full and completely illuminated. This is not the case for two reasons. Most importantly, Venus is fully illuminated when it reaches superior conjunction, meaning it is on the other side of the Sun from us, and the bright light from the Sun makes it impossible to see. Additionally, even if we were able to see it at this point in its orbit, the fact that it is furthest away from us would greatly diminish its brightness. As you can see from this graphic, maximum brightness is achieved when the planet is 39 degrees from the Sun in the sky. This is a sweet spot in that the distance from Earth and the percentage of the planet that is illuminated combine to give us the most observable light here on Earth. Speaking of brightness, Venus's proximity to Earth is not the only factor contributing to its brightness. Sulfuric acid clouds in the upper atmosphere of Venus are excellent reflectors of sunlight, making Venus highly reflective overall. All told, Venus is the brightest planet in the sky and is 10 times brighter than Sirius, the brightest star in the sky. If we go beyond the sulfuric acid clouds that envelop Venus, we discover that its atmosphere is almost completely made up of carbon dioxide. Compared with Earth's atmosphere, Venus has an atmosphere that is 90% more massive than that of Earth's, which coincides with the pressure that is 90 times that of Earth's. The intense pressure makes it very difficult to explore the surface of the planet. All probes that have managed to land on its surface have only lasted a very short amount of time due to being crushed or melted. It is believed that Venus and Earth began in similar fashion, with atmospheres that mimicked each other. Early on, carbon dioxide became dissolved in the oceans or absorbed into rocks on both planets. This was short-lived, however, and the planets went on to evolve in very different ways. Earth's carbon dioxide continues to be dissolved and absorbed to this day, leading to the hospitable planet that we know and love. Venus wasn't so lucky. Venus has fallen victim to the runaway greenhouse effect. Twice as much sunlight hits Venus due to it being 30% closer to the Sun than the Earth. Because of this, Venus began to lose its liquid water via evaporation early on in its history. This led not only to the introduction of water vapor, an effective greenhouse gas in its own right, but the release of carbon dioxide that was previously dissolved into the atmosphere. This steady rise in greenhouse gases meant a continuous rise in temperature and the eventual loss of water altogether, leading to the runaway greenhouse effect that has heated the planet to a blistering and solar system best of 730 Kelvin. The thick atmosphere, intense heat, and crushing pressure of Venus make exploration of its surface difficult, but not impossible. Thanks to radar, which can penetrate Venus's atmosphere unimpeded, the topography of the planet can be mapped with great accuracy. These images were created using radar. The left image was derived from the Pioneer spacecraft, and the right image is a mosaic of images obtained from Magellan. Comparing the topography of Earth to Venus using similar methods reveals how much the two surfaces resemble one another. Venus does not exhibit the range of elevations seen on Earth, making it flatter. Also, the elevated areas on Venus are reminiscent of Earth's continents, and the lowest elevations on Venus look like Earth's ocean basins, even though Venus is devoid of water. It is also of note that the phenomenon of plate tectonics is absent on Venus and that most, if not all, of Venus's volcanic activity occurred in the past. Despite having a core similar in composition to that of Earth's, Venus has a virtually non-existent magnetic field. This can be attributed to the extremely slow rotation of Venus, depriving the core of Venus the opportunity to create convections that would lead to the dynamo effect that we observe here on Earth. Consequently, the lack of magnetic field has many secondary effects on the properties of Venus. The most significant of these is probably the inability of the planet to protect itself from the ionizing solar wind emitted by the sun. This is believed to be a major factor in why the planet lacks water. Ultraviolet light likely broke water molecules down into hydrogen and oxygen over time. Further compounding the issue, these lighter elements rose to the top of the atmosphere, where they were stripped away from the planet by the unimpeded solar winds. This eventually led to not only the loss of water, but also the loss of the components of water, and resulted in the dry conditions we see on Venus today. The former Soviet Union launched the Venera missions that took place from the late 60s to the early 80s. These groundbreaking missions had Venus as the sole target and were the first ever missions to feature landings on another planet. Among the accomplishments of these missions was the first mission to transmit data from another planet's atmosphere by Venera 4, the first ever landing on another planet by Venera 7, the first images from the surface of Venus by Venera 9, the first color images from Venus by Venera 13, and the mapping of Venus's surface using radar by Venera 15 and 16. These missions remain notable accomplishments due to the extraordinarily harsh conditions on the planet. The United States began to explore Venus via the Pioneer missions in 1978. Two spacecraft were sent to the planet to orbit it and explore its atmosphere and the surface with their probes. The missions were a success and helped pave the way for the Magellan mission. The Magellan mission was launched in 1989 and reached Venus in 1990. Its primary objective was to map the entire surface of Venus using radar. The mission was a success, and almost all of the surface was mapped, yielding a detailed account of Venus's topography that is still useful to this day. Additionally, the mission revealed evidence of past volcanic activity. The bottom right image, for example, shows where molten rock was forced from the surface to form dome-shaped structures on the surface of Venus. Magellan was intentionally crashed into the surface of Venus in 1994, but was still collecting data on Venus's gravity and atmosphere until the very end. NASA shifted its sights to Mars after Magellan and has only recently started planning a return to Venus. Currently, two missions are planned. One is Veritas, which stands for Venus Emissivity, Radio Science, INSAR, Topography, and Spectroscopy, and will be carried out by an orbiter that will scan the planet with far superior technology to what previous missions utilized. The other is Da Vinci, which stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, and will involve flybys and a descent probe to explore the properties of Venus. And finally, I want to share a few random facts about Venus that didn't quite fit anywhere else in the presentation. Venus can be so bright at times that it is able to cast a shadow when there is no light pollution and the moon is absent from the sky. Venus is literally hotter than a pizza oven, by a lot. If you were to stand on Venus, the sun would rise in the west and set in the east due to its retrograde rotation. The morning star and evening star versions of Venus were once thought to be two entirely different objects in the sky because they appeared on opposite sides of the sun. Thanks for listening, and I hope you enjoyed this presentation on Venus.